Hey everyone, and welcome to our deep dive. Today we're going to be looking at something that's honestly kind of overlooked a lot of the time, but it's seriously crucial to our modern world. Batteries.
Absolutely.
We're talking centuries of history and tech here, and believe me, it gets a lot more interesting than you might think.
Oh, for sure.
So to kick things off, we've got a timeline that takes us through all the major milestones in battery development, from the very first discoveries to, well, the cutting-edge stuff that's being worked on right now.
It's a wild ride from, zapping frog legs to the smartphones in our pockets.
Speaking of frog legs, that's actually where our story begins. Back in 1780 with a scientist named Luigi Galvani.
Yeah, Galvani was doing some experiments with frog legs, and he noticed something pretty weird.
Uh-oh, this sounds messy.
A little bit. He saw that when he touched a frog's leg with two different metals, the leg would twitch.
Wait, really? Just from touching it with metals?
Yep. He thought he'd discovered what he called animal electricity, like there was some kind of inherent electrical force inside living things.
So, like, frogs had superpowers.
Well, not exactly. His theory wasn't entirely accurate, but it got people thinking about the connection between electricity and metals in a whole new way.
And that's where Alessandro Volta enters the picture, right?
Exactly. Volta took Galvani's observations and was like, okay, there's something going on here. And in 1800, he invented something called the Voltaic Pile.
And what was so special about this Voltaic pile?
It was the first true battery. Imagine this. Stacks of zinc and copper discs separated by cloth soaked in salt water.
Sounds pretty DIY.
Right, but it worked. It was the first device that could produce a continuous electric current.
So no more messing around with frog legs.
Haha, no more frog legs. Volta's invention was a major breakthrough. It set the stage for, well, pretty much all the batteries that came after.
Amazing to think that something so simple could have such a huge impact.
It's a testament to scientific curiosity and, sometimes just stumbling upon something unexpected.
So we've got this first battery. What happened next? Our timeline shows a lot of activity in the 1800s.
Yeah, that's when things really started to take off. There was a ton of experimentation and innovation going on.
What kind of improvements were people making to these early batteries?
It was all about making them more practical, more reliable, One big issue with early batteries was that the current they produced was all over the place, not very consistent.
Oh, I bet that was frustrating.
Totally. But in 1836, a guy named John Daniell came up with the Daniell Cell.
Ooh, another scientist with a cool name?
Right. And his cell was a big improvement. It provided a much more stable and reliable source of power.
I'm sensing a pattern here. So first, you have the big breakthrough, then it's all about refinement and making things actually usable.
Exactly. And the next big step in that direction came in 1866 with Georges Leclanché and his Leclanché cell.
Okay, so what did Leclanché do?
His invention was a precursor to the dry cell batteries that we use today. Before that, batteries were mostly these wet, messy things.
Yeah, I can imagine that wasn't very convenient.
Not at all. So Leclanché cell was a big deal for portability. Of course, the first true dry cell battery didn't come along until 1887, thanks to Carl Gassner.
So Gassner finally figured out how to make a battery that didn't leak all over the place.
Pretty much. His dry cell battery was a game changer. It meant you could have portable power for things like flashlights, for example.
That must have been amazing at the time. No more lugging around big, heavy, wet batteries.
Right. It opened up so many possibilities.
So things are getting smaller, more portable. What's the next big leap?
Well, up until this point, all these batteries were single use. Once they ran out of juice, that was it.
You had to throw them away.
You got it.
Yeah.
But then, at the end of the 1800s, something revolutionary happened. Rechargeable batteries.
Okay, this is huge.
Oh, it was massive. Imagine not having to constantly replace your batteries.
Yeah.
And this was driven by, well, the world was changing. There was a growing demand for power, especially for all these new technologies that were popping up.
Makes sense. So who are the pioneers of this rechargeable revolution?
One of the first big names was Waldemar Jungner. In 1899, he invented the nickel-cadmium battery, or NiCed for short.
NiCed sounds familiar. Weren't those the rechargeable batteries we had, like, way back in the day?
They sure were, and they were a big deal because they had a higher energy density than previous batteries. Basically, you could store more power in a smaller package.
So things are getting more powerful, too.
Exactly, and just a couple of years later, in 1901, Thomas Edison came along with his invention.
Hang on. The Thomas Edison. Like light bulb Edison.
The one and only. He developed the nickel-iron battery, also known as knife.
What was special about Edison's battery?
It was incredibly durable, like seriously tough. You can still find nickel-iron batteries being used today in some industrial applications.
Wow, they must have been built to last.
They were, and they highlight another trend we see throughout battery history. It's not just about inventing something new, it's about making it better, more efficient, more durable.
So we've got these rechargeable batteries. Where does solar energy fit into all of this?
That comes a bit later. The first practical solar cell was developed in 1954.
Okay, so mid-20th century.
Right. And this was a game changer for renewable energy. Suddenly, we could harness the power of the sun to directly power our devices.
I bet that blew people's minds at the time.
It did. It opened up a whole world of possibilities for clean, sustainable energy. Of course, solar technology has come a long way since those early days.
And that's a whole other deep dive.
Absolutely. But in terms of batteries that most people are familiar with, we can't forget about the alkaline battery.
Oh yeah, those are still everywhere. When did those come along?
The alkaline battery that we know and love hit the scene in 1959 thanks to Louis Uri.
What was so great about alkaline batteries?
Well, compared to previous battery types, they had a longer lifespan and could hold more energy. And they were more reliable, too.
So basically, better in every way.
Pretty much. Alkaline batteries quickly became the go-to choice for all sorts of everyday devices.
Okay, so alkaline batteries, rechargeable batteries, solar cells. We're getting closer to the modern battery landscape.
We are. But to get there, we have to talk about the rise of lithium batteries. I mean, they're everywhere today.
Seriously, they power our entire world.
No exaggeration. The development of lithium batteries in the 1970s was a turning point, particularly for portable electronics.
Yeah, what would we do without lithium-ion batteries in our smartphones and laptops?
Exactly. And the key to their success is their high energy density. You can pack a lot of power into a very small and light battery.
So was there like a single eureka moment that led to lithium-ion batteries taking over the world?
Well, there were lots of incremental improvements over time, but one of the most crucial came in 1980 with John B. Goodenough's work.
Another big name in battery history. What did Goodenough do?
He developed the lithium-ion battery cathode material, and this was a huge leap forward because it significantly boosted the energy density of these batteries.
So more power in an even smaller package.
You got it. And just over a decade later, in 1991, Sony commercialized the first lithium-ion battery. And, well, the rest is history.
It's mind-blowing to think how much we rely on that single invention. It truly revolutionized the world of portable electronics.
Totally. And it paved the way for the smartphones, tablets, and all the other portable devices we use every day.
So we've come a long way from zapping frog legs. What's next for batteries? What does the future hold?
Well, the research and development never stops. In the 2000s, research into solid-state batteries started to gain traction. These batteries have the potential to be even safer and more energy-dense than lithium-ion batteries.
Safer. How so?
Lithium-ion batteries, while amazing, do have a slight risk of overheating and, in extreme cases, even catching fire.
Oh, right. I've heard about that.
Solid-state batteries eliminate that risk because they don't use flammable liquid electrolytes.
So that's a big plus for safety. And what about this increased energy density? What would that mean for us?
Imagine smartphones that stay charged for days, electric cars that can travel much farther on a single charge.
Okay, now we're talking. Anything else on the horizon?
There's a lot of focus right now on developing even more sustainable battery technologies. Things like sodium-ion batteries and lithium-sulfur batteries are being researched heavily.
Why are those more sustainable?
Well, they use more abundant and less environmentally harmful materials than lithium-ion batteries.
So it's not just about performance, it's about making sure that our battery technology is good for the planet too.
Exactly. It's about finding that balance between meeting our energy needs and protecting the environment.
It's amazing to see how far battery technology has come, from those early experiments with frog legs to the sophisticated powerhouses that drive our modern world.
And it's clear that the journey is far from over. What's so exciting is that the pace of innovation is only accelerating. Who knows what incredible breakthroughs the next few decades will bring?
It really makes you think, doesn't it? How will these new battery technologies shape the way we live, work, and power our world? And what kind of world will we create with all this newfound energy at our fingertips?
It's definitely something to ponder. The future of batteries is full of possibilities, and it's going to be fascinating to see how it all unfolds.
Well, on that note, thanks for joining us on this electrifying deep dive into the history of the battery. Until next time.